All right, I think we're finally ready to start. Sorry for the bit of a wait, but hopefully we're good to go. All right, let's give Miranda a round of applause, please. Thank you.
Hello, everyone. I hope that you are having a wonderful day so far. I am super excited to be here today. This is actually my first time speaking at a large conference, so woohoo, yeah, thanks for the enthusiasm, woo. So today we're going to be looking at animating with FuncAnimation specifically, which is a matplotlib class. So a quick intro on myself. I had a wonderful introduction already, but my name is Miranda Auhl. I'm a developer advocate at Timescale, which Timescale is a time series database built on Postgres, so that's kind of where I'm coming from. And then I included my GitHub first because I will be showing some code snippets in the talk today, but I won't be going into like super detail. So if you want to make sure that you can see like all the detail that you want in the Python script that I'm going to be kind of walking through today, you can access it through my GitHub account. So don't worry if you don't. If you skip something now, you can look at it later or ask me questions also. And I'll have a link to the exact repository at the end of the talk as well. And then that's just my email and also my Twitter handle. So feel free to reach out at any time. So I want to take you on a journey, and unfortunately not a hobbit's journey, because that would be awesome, but my journey from taking a static graph and transforming it into a data animation. And on this journey, we're going to walk through, this is kind of like the setup and the path that we're going to be following. So first, right, before we can really visualize any data, we have to understand the data and actually grab the data, important. Then we'll look at actually creating a static visualization. And then the last thing that we'll look at is actually transforming that static visualization into a data animation. So we start off, as you probably could expect from the name of this talk. We're starting off with NFL and NFL data. So in 2015, the NFL did something really interesting. They started requiring that every stadium have RFID receivers and that every player have RFID tags, and the ball as well, actually, have RFID tags that track every 1/10 of a second all their movement, speed, acceleration, all this stuff. So as you can imagine, we have, from 2015 to now, the NFL tracking, speed, acceleration, all this stuff, every 1/10 of a second for every player, for every single game. That is a lot of really cool time series data. And what's amazing and blew our minds at Timescale was that the NFL actually gave access to people to access this data for free. Insane. Like, I could not believe that the NFL released free data for anyone to analyze. All you needed to do is have a Kaggle account. So starting in 2020, the NFL started these big data bowl competitions where they released a subset of this awesome time series tracking data. And you could, download the CSVs and analyze it. And specifically in the 2021 Big Data Bowl competition, they released a bunch of the 1/10 of a second tracking data available, and with kind of a bend towards passing plays specifically. But it's still, they can't release, of course, all the data because, they don't want to release everything to the public, but they did release a huge portion. And so when my team and I found out about this, we were like, whoa, with great time series data comes great responsibility to analyze it. That's how the saying goes, right? Well, we're just going to roll with it and say that that's how it goes now. So all analysis, right, we saw this data. We knew that we wanted to analyze it. So the first step is actually getting to know the data, right? And so this is one table that you can access through the 2021 Big Data Bowl competition. So this is the tracking table, which is tracking that 1/10 of a second kind of IoT readings, basically, of the players and the ball. And this is actually a subset of the columns that you have access to in that competition. So we see that there's a lot of data here. And first, I want to start off by just going through each column and just kind of like helping everyone to get to know the data a little bit. So first off, we have time, which is a timestamp column. And we see that it is incrementing and a 1/10 of a second time stamp. So first we see that we have 14.599, essentially 14.6 in kind of the far left end of the timestamp, or the far right, excuse me. And then the next timestamp is 14.7. So we're getting 1/10 of a second readings in this data. So it's really granular. That's super fun. That means that there's a lot of possibility for how you can analyze this data and aggregate it and stuff. And also notice that we have a bunch of repeated rows for each timestamp. And that's because the NFL, they put RFID tags on all the players and the ball. So each player and the ball is going to be taking in a reading for every 1/10 of a second. Now in this case, since again the NFL can't release all of the data to us, they did though release for this data set all the most important players for a specific passing play and the ball for each 1/10 of a second. So that's why you see 14 rows here. So that's 13 of those are going to be players, one of which is going to be the ball. So cool beans. Next up, we have X and Y. X and Y are columns that represent X and Y coordinates on a coordinate plane. The NFL set up the field, the football field, so that they could take in basically as an XY coordinate plane so that you could find out the location of any player or the ball at any moment in time during any of these games. Pretty sweet, right? And so that's really what these XY coordinates are. It's yards, it's in yards, and it's saying exactly where that individual or the ball is at any given time. So then next we have speed, which that S is representing the speed of the individual at that moment in time. Then we have acceleration, is what the A stands for. Game ID, which is a unique identifier for each game. Got to know which one is which, good to know. And then this play ID is specifying, since this data is kind of bent on just showing passing plays, this play ID is a unique identifier for us to know within a game a specific passing play. So that's what that play ID is. And then this last column is kind of important and what we're going to dig into a little bit more in today's talk, but it's this frame. And kind of at first glance, it's not super clear what it is. Essentially, this frame column is taking every 1/10 of a second and mapping it to an integer value. And it's not only just mapping it to an integer value, but it's mapping it to an integer value that's increasing continuously with time. So as you see, the 14.599 1/10 of a second is mapped to a frame value of 1, and the 14.7 second, 1/10 of a second, is mapped to a frame value of 2. So we see that as time is increasing, that frame value is increasing. And another note that when we looked at this data more is that for every play ID, it will count every 1/10 of a second and map each 1/10 of a second to the frame. But then as soon as you hit a new play value, so if we were to go to 76, the frame value would kind of restart at 1. So essentially, we know from this data that 14.599 1/10 of a second was the first 1/10 of a second to occur in the 75th play. And then, the 14.7 was the second 1/10 of a second to occur in the 75th play. So these frame IDs are unique to the play. All right, so we get to know our data. Now, we can get to the fun stuff. We can actually analyze it. We can create visualizations. And so one of the visualizations that I wanted to know was, well, we have these XY coordinates. Let's actually plot these players on a field, right? That seems kind of fun. And we have the information. Let's do it. So I created a script, and I set up my Python script kind of with an argument, because I wanted to focus on one play at a time. And so I defined the game ID that I wanted to look at, and then the play ID that I wanted to kind of zoom in on and graph the data from. So I define that, and then I also pull in my data from my timescale DB database. So I'm pulling that data into my Python script for this specific play, so then I can really dig in more and analyze it. So then I have data in my Python script. What's next? Well, if I'm going to plot players on a field, I'm going to need a field. So what I did was that I created a generate field function, which I could just call that and get this awesome field. So I made it so that I kind of like smush all of my matplotlib functions into one, kind of wrap them all up into one function so that I can call that generate field and get, you know, the yard lines and the hash marks and all this good stuff. So then, right, we have a field, but now we need to actually plot the players. So I created another function. I created a draw play function. And this draw play function takes in a value of a frame, so it takes in a frame argument, and it's going to draw a play, kind of plot a play from that frame. So with the frame value, it represents, right, a moment in time. So I can put in a moment in time and get this get this plotted. So with this function, I made it so that I plot. Oh, this is just, you know, showing us the frame value. So with this plotting function, I take in you know, that frame value, and then I can actually plot the players. I created a legend, and I also get a title. So, all right. So now, in order to actually create the function and plot it on a graph, I made it so that I can just call these 4 lines of code and get, you know, this static plot that I wanted. And so the first line is a figure, so I'm creating a matplotlib figure. Second line is I generate the field, so I produce the field on the figure. Third line is that I'm calling the drawPlay function for a frame ID value of 65. And then the last line is plot show that actually shows us the plot in, you know, so that we can see it. So this is the 75th tenth of a second for this specific play that I'm kind of digging into for this script. And so, you know, we have the home team, away team, we have the football, and like, you know, this is pretty cool. You know, this is an interesting graph. I can see that, like, I see the players on the field, but like, you know, is the ball being passed right now? It seems to be kind of floating in air. No one's really attached to it. So really, this static plot, I was like, it's not really doing it for me. And so I asked the question, well, what if I could animate it and actually not only just animate the players' movements as they were going through this play, but also see historically where they went as they went through the play. And this is really where FuncAnimation comes into play. And so, but in order to understand how to use FuncAnimation, I really feel that you have to understand how animations work in general, because they tie directly together. So let's consider a flipbook. So a flipbook is, you know, traditionally, it's usually a set of static drawings that you flip through really fast to kind of give this illusion of motion. And so that is exactly, I actually created a digital flipbook with my iPad, and so I drew a bunch of static images of this pink ball, okay? Each one is just a static image, you know, cool beans. I get this static image, awesome. Well, what's super cool is that when you play these static images one after the other in sequence, you get an animation, right? You take these static images, you string them together, and you get an animation. And that, folks, is exactly how FuncAnimation works. It's basically a fancy digital flipbook. So how the process works is that FuncAnimation takes a static graphing function and it iterates over that function again and again. So it produces, you know, the static graphing function produces a graph. So FuncAnimation iterates over that, and it's creating all these static graphs, which it then kind of puts all together, plays one after another to create an animation. So if we're going to use FuncAnimation in our code, we got to understand how to use it, right? So here, I took this from the matplotlib documentation, and this is just like all the arguments that we would need if we were going to use FuncAnimation. And I highlighted the 2 necessary requirements that you have to include when using FuncAnimation. So the first one is fig. Fig requires a figure, matplotlib figure object that it can kind of produce this animation on. And then func represents a plotting function that that FuncAnimation can actually iterate on to create all those static graphs, which it will then, you know, mesh, kind of weave all together. And hopefully at this point you're like, wait a minute, I think we have that. I think we have these exact 2 things, and we do, in fact, by setting up the static graph like this. We create a figure. That's the first line of code that we do. Cool. We got the first requirement. Awesome. And then the third line of code calls the drawPlay function. And we know that drawPlay function is, in fact, an iterable function. And that is because of the frame. This frame, right, is directly tied to time. So as we iterate over this frame value, we're going, 1, 2, 3, through these integer frame values, right? We're actually iterating over time. We're looking at the first tenth of a second, the second tenth of a second, and continually on and on and on. So when we iterate over this frame, we're actually iterating over time, and that's exactly what we want to plot, right? We want to plot the player's movements on this field over time. And so we have the two requirements. Well, now the next question is, can I just, throw it into the FuncAnimation function and we're good? And the answer is basically yes, but we need to do just a few quick adjustments to make sure that it works. So one thing is that if we were to animate our drawPlay function as it is right now, where I plot the figures on the field, create the legend, create the title, we would get something like this. Not ideal, right? This is not exactly what we want. So like the player's movements, that's good, right? I want to see how the players are moving over time, and I want to keep their historical movement in view. But this legend is a problem. And so that takes me to wanting to talk about these two types of functions that you can use when you create your iterative function that you're going to insert into FuncAnimation. And that is plotting functions, plotting function types versus setting function types. So plotting function types, I highlighted the three functions that I call, the three types of functions that I call my iterative function, my drawPlay function. And this plot function that we're going to look at first, that is truly a plotting function. It's additive. As the animation is continuing, it's adding plots to the animation. So every time drawPlay is called, this plot function is going to add a new plot to the animation. It's additive. So that's what plotting functions are, additive, okay? I'm saying that a lot. My apologies. You'll just remember it now forever. So then the next function that we're going to look at is setTitle. This function is a setting function. It's going to replace. So plotting functions add when you animate. Setting functions replace when you animate. And so the title, it's not really causing a problem. Probably, every time drawPlay is called, it's setting the title. So maybe for efficiency's sake, we might want to move it out. But I'm just going to leave it there for now because it's not causing tons of issues. But the legend, the last function, this is a problem, right? This is actually acting as a plotting function, right? Because it's adding a legend every single time the drawPlay function is called. So this is a problem. Easiest way, we remove it. And we move it to the generate field function, which we only call once. So that just makes it easy. It's an easy way, quick fix to remove that plotting function that is doing what we don't want it to do. So then the next caveat you want to make sure is that whenever you create your iterative function, the value that you iterate over, or the argument that you iterate over, has to be the first argument specified in the definition. So for drawPlay, right, it doesn't matter. We have only one argument value. But say that I had two other arguments in my iterative function. I need to make sure to call frame first, and then all the other arguments after. So that's just something that FuncAnimation really looks for. It will not work if you don't put that iterative argument first. Okay, so now we can actually create our animation. We can transform that static graph into an animation. So here is a static graph Python code, and we have FuncAnimation at the top, the definition just for reference. So first off, we need to actually insert FuncAnimation into our code. Cool beans, we put it in. The thing is that FuncAnimation, it needs to store the animation into a variable. And so in this case, I called my variable anim, represents animation. And then it's just one of the requirements with FuncAnimation. It has to have somewhere to store the animation. So you create that variable. Next, you have the two required arguments. So first, right, we have fig. We throw our fig in there. And then draw play, which is the iterative function, right? That's the next required argument. And we just call the name. You don't add any of the arguments, you just call the name of the function and you throw it in there. And then lastly, I wanted to also, oops, sorry, I forgot the mic was there. I also wanted to specify the frames that FuncAnimation is going to iterate over. By default, FuncAnimation will iterate starting at an integer value of 0, and it's going to iterate over integer values. So it goes 0, 1, 2, on, so on and so forth. In our case, right, we like the integer value. We want to iterate over an integer value, but we want it to start at 1 and iterate over the integer values. So we can actually specify the exact range of values we want FuncAnimation to iterate on. And in this case, right, I want values starting at 1, going at increasing by 1, and then this 113 is just the max value for the frame for this specific play. So I just put bounds around all the frame values. So that's where I get that 1 from, because we're starting at 1, and it goes all the way to 113. And then, friends, well, now we can actually comment out the draw play frame function that we call up there and the plot show there for the static graph. We can comment that out and now put plot show underneath our animation. And, oh, it doesn't get, okay, that's okay, because I have another graph here. That's okay. I have a GIF of it, so no, not a problem. Technical issues, folks. Gotta love it. Okay, and I think I can go to the next slide. You can just, yeah. So okay, so this is an added animation that I was hopefully going to show after the first animation. But what's cool, right, is that I took this static plot, and so you can ignore the jersey numbers. Those are jersey numbers that I added. And right, this is far more interesting. Now we can actually see how this play, we're not getting a snapshot of just seeing, the ball floating in space. Now we actually see the pass being thrown. This person is like just about to score a touchdown and actually does. This is super fun and way more engaging. And what's cool is that once you have an animation like this, you can add to it like I did here. So in this case, I used a setting function, a setting type function, to add the jersey numbers for each individual. So that we know who's, getting past what, or who's, tackling whoever. And I also added some statistics tables. And you could even add statistics to the individuals if you want on the graph. The possibilities are endless. So how can you use animation? Well, as long as you have a figure, you have a matplotlib figure, and an iterable plotting function, then you can animate it. That's really all you need. And especially if you have kind of set yourself up with avoiding kind of the whole plotting setting type functions and also making sure that that iterable frame value is the first, like you can animate it. And I hope that you feel encouraged to actually try this out in your static plots at home. And so, folks, that's it. That's pretty much it. Here are some resources. So this first link is a link to my GitHub project. I include all of the slides and also the Python script that I ran through here. It's the full script, so you get all the code that I didn't here. The second is the Kaggle competition link for the 2021 Kaggle competition, so you can download the data yourself. All you need is a Kaggle account. And then the third and fourth links are actually, the first one is a tutorial that my team made to help you basically walk you through ingesting the data from Kaggle, putting it into a timescale DB database, which is basically Postgres, and then, lost my train of thought, and then actually analyzing it. And then the last is just a blog post kind of diving into other analytics that you could try out. So that is it. Happy coding, friends. Thank you so much for being so patient with all of these technical issues, and I hope that you have a wonderful rest of your day. Yes, thank you. Also, if anyone wants stickers from Timescale, come see me, or if you have questions, also come see me. So thank you.